Push that rock with Simpson math. Let's estimate the value of a convergent series, and let's let it be this one. Now this convergent series has this interesting -1 to a power in it, and we're going to see what that does. So the first thing I like to do is take the argument of the series. Here was the argument of the series, this sequence, and look just at the sequence alone. So I'm going to put in 1 for the ends. So I get -1 to the 1 plus 1, because I put this 1 in for that end, over 1 squared plus 2. Well, that gives me -1 squared over 1 squared is 1 plus 2 is 3. And anytime you square a negative, you get a positive, so 1/3. Let's do it again with 2. So we put in -1 to the 2 plus 1, and this time we realize, oh, that's going to be to the 3rd power. And so we realize, wait, that's going to be a -1, when negative to an odd power is going to be negative. Meanwhile, we put 2 in for that end also, so we have 2 squared plus 2. Well, that's 4 plus 2, so that's 6. Okay, let's put in 3. Now, I think we can figure out the top. If we put in 3, 3 plus 1, it's going to be 4, and it's going to be a +1. So it's just going to alternate from 1, -1, 1, -1, and so forth like that. So I think that's, we can dispense with the numerator now. Now 3 squared is 9 plus 2 is 11. And 4 squared is 16 plus 2 is 18. And 5 squared is 25 plus 2 is 27. And 6 squared is 36 plus 2 is 38. And so I have 1/3, -1/6, 1/11, -1/18, 1/27, -1/38 as my first term. And remember, what does the series do to these terms? That's my first 6 terms. What does the series do? This symbol means add them up. So we're going to add up that 1/3, that -1/6, the 1/11th, the -1/18th, the 1/27th, and the -1/38. And the series keeps going. But we're going to add these up. In fact, let's just add up these. And what I'm thinking here is, I'm thinking, this is about, 1/40th. 1/40th is about 0.025. So, this is really small. I don't know what it is, but it's really small. And notice, we start at 0.33333, 1/3. We take a little bit away, like we take away 0.16 repeating sixes, so 0.16666. And then we add back in 1/11th. Well, 1/11th is about 0.09 repeating. So we take away less than 0.2. We add in less than 0.1. Then we take away 1/18th, which is another less than 0.1. That's like 0.05-ish. And then we add in even smaller. So for every time we take away, we add in a little bit to compensate. But then we take away some more, but we add some more to compensate. So it's going to be smaller than 1/3. But I feel like it could add up to a number, because all of these terms start getting so negligible that the change stops being significant enough, so that we're definitely not going to get below 0. So if we're not going to get below 0 and we're going down, we must be going down to some number. And that's the number we're trying to find. And we were told that it was convergent. So that means it does add up to a number. So we have some faith that this adds up to a number. And since we have faith that it adds up to a number, we'll add up just these and use it as our estimate, because we realize the change is not going to be that significant. Even though there's an infinite number of numbers being subtracted and adding in, it's just not going to be that significant. So we'll just add these. Well, I got to get a common denominator here. 1/3 and 1/6 have a common denominator of, say, 12? No, just 6. What am I saying? We'll just do 6. We'll just make a 1/3, 2 6. And I'm going to bring, kind of ignore the others, but I'm going to change my order a little bit, because I see that 6 will go into 18. So I just changed the order, and that's okay by commutative property. And this gives me 1/6 minus 1/18. Meanwhile, over here, I'm going to get a common denominator. Let's see. There's a trick for multiplying by 11. If I multiply 27 by 11, I'll get 297. And if I multiply 27 by 11, I have to add and get 11. So that means this is 297. I have to multiply 1 by 11 also and get 11. But I just multiplied 11 by 27, so I multiply that one by 27. So I get the equivalent fractions with a common denominator. Here we need to get another common denominator to make it 18. 6 goes in 18 3 times. Let's see, we add that up and we get 38 over 297. Now 3 18ths minus an 18th, that's 2 18ths, which is a ninth. Right? 2 18ths is 1 ninth. And so then we say, okay, we have to add this up. Well, let's see. 9 will go into 27 3 times, and there's a remainder of 2, so 33. So it goes in 33 times. So 9 goes into that number 33 times, so we multiply the top and the bottom by 33, and we have a common denominator. And we add those two up, and we'll have 297 in our denominator. And then, let's see, 30 and 30 is 60. And then we add an 11 to that, so we have 71. And so this is our estimate. Now we're estimating, and we know this isn't it exactly, because we're going to take away 1/38 and then add in the next number, which is even smaller than this in magnitude, and then subtract, and so forth and so on. So let's just try to get a realistic picture of what we think that is about. Well, if that was 70 over 280, we'd have 7 over 28, which is 1/4. So this looks like it's a little smaller than that. So maybe 0, since 1/4 is 0.25, maybe it's 0.24. Because, we only changed the numerator by 1, but we changed the denominator by 17. So I feel like we made it smaller. So it's a little bit smaller than 1/4. So we think that this convergent series that looks like this, kind of complicated, starts at 1, goes on forever, is approximately equal to 0.24. And that's a fair estimate of the value of this series. And in fact, I think the error is in the hundredths place. If there's error, it's in the hundredths place, not in the tenths. So it is 0.2 something. And you could Google it. Maybe there's a calculator online to give you the exact value. Well, the exact value may not be known, but it's going to be really, really close to this. This is a reasonable estimate for this convergent series. Math made simple. It's some math.